I am Dr. Samanthi Konarasinghe from Institute of Mathematics and Management, Sri Lanka. Today I am going to talk about Summer's circular model and ARIMA on stock market forecasting. Introduction to the research. As we all know, stock market plays a vital role in the economy of a country. Among all the markets, Indian stock market has a prominent place. Why is that? Performances of Indian stock market affect the nearby markets as well as the faraway markets. Indian stock market comprises actually two main markets, Bombay Stock Exchange and National Stock Exchange. Among them, Bombay Stock Exchange is the oldest. So in this research, my concern is about that. Why it is important to do research on stock markets? Or why stock market forecasting is important? Stock market investments are at high return. It is interesting, but it is associated with high risk. So investors need high returns, but not high risk. Therefore, they are very much concerned in market forecastings. Stock market indices give insights for investors to foresee the return and risk. That's why research on stock market investments are so important. A stock market comprises large number of companies based on the market capitalization. Companies are divided into three main parts: large cap, mid cap and small cap companies. There is a belief that the investments in large cap companies are less risky. It is true. However, there is a concern on investing in large cap companies. In Bombay Stock Exchange, the S&P BSC large cap index is used to measure the performances of those companies. When we look at the stock market forecastings in Bombay Stock Exchange, the ARIMA technique was highly successful in many cases. ARIMA is a well-known technique, is successful in almost all the fields. However, ARIMA has some known weaknesses. One thing is, ARIMA is unable to capture the cyclical variations. Also, ARIMA is applicable only for stationary series. Stationary series means a series with constant mean and constant variance. Also, many studies have given evidences that the ARIMA forecasts do not follow the patterns of actual data. That is the main weakness identified in ARIMA. The Summer's circular model or SCM is a new technique introduced in 2018. It is capable in capturing trend, seasonal and cyclical variations of a series. Also, literature gives evidence that the SCM forecast follow the patterns of actual data. Based on the literature, I intended to test the Summer's circular model on forecasting S&P BSE large cap index, use the ARIMA for the same purpose and comparing the forecasting ability of two models. When it comes to the materials and methods, this study is based on the SCM of Konarasinghe 2018 and ARIMA model of Box and Jenkins 1970. As usual, the pattern recognition was the first part of the study based on time series plots and autocorrelation functions. Then the tentative models were selected and model testing was done with 2/3 of the data set and 1/3 was kept for the model verification. The autocorrelation function of residuals and LBQ test were used to test the independence of residuals. The probability plots and the Anderson-Darling test were used to test the normality of residuals. Forecasting ability was assessed by mean square error and mean absolute deviation. The Sama circular model, or SCM, it was developed by Konarasinghe 2018. Actually, that is me. The development of the model was based on the motion of a particle in a horizontal circle and Fourier transformation mainly. As you know, the Fourier transformation has two versions, discrete version and continuous version. Here the discrete version was used. As Fourier says, a wave can be splitted into packets of waves. When we look at the motion of a particle in a horizontal circle, to complete one cycle, the time taken by the particle is known as the period of oscillation. It is given by this formula, T equal 2 pi over omega. Actually, the initial development was the circular model, not the Sama circular model. What the circular model says is a random variable can be modeled by series of trigonometric functions and a random error component. Konarasinghe 2016 has shown that this omega can be calculated by this formula, omega equal 2 pi f over n, where f is the number of peaks in a time series and n is the total number of observations in a series. Model assumptions were mainly these trigonometric series are independent, and the error component, random error, it is normally distributed and independent. So to calculate the amplitudes AK and BK, least square regression method was used. This was highly successful in many real-life examples, but the circular model has one weakness or limitation. That is, the CM is unable to capture the trend component of a series. Konarasinghe 2018 has improved the model incorporating the differencing technique. Accordingly, the improved version of the circular model or the Sama circular model is given by this formula. Present value depend on past lags and some trigonometric functions with the error component. The autoregressive integrated moving average model, or the ARIMA, is a well-known technique. According to ARIMA, present value of a series can be forecasted by past lags or the past values and past errors. Here, yt is the actual value, epsilon t is a random error, and phi p and theta q are the coefficients of autoregressive and moving average respectively. B is the backshift operator in usual notation. In model testing, monthly S&P BSE large cap index from 2005 to March 2019 were used. Time series plots were used for pattern recognition. Then the goodness of fit test, measurements of errors, and plots of actual versus fits were used for model validation. This is the time series plot of the index. It is clear that the index has a increasing trend throughout. However, the fluctuation also very high. Altogether, this plot is an irregular wave with a trend. Then, the Sama circular model and ARIMA were tested. When testing the Sama circular model, first omega was calculated, and using that omega, trigonometric series sin k omega t and cos k omega t were obtained for various k values. K is a positive integer. So based on the obtained trigonometric series, Several models were tested. Accordingly, the best fitting Sama circular model is this: yt equal yt minus 1 plus a constant minus a trigonometric part. It says the present value depend on past legs, actually a leg 1, and sine 5 omega t function. Errors of this model were normally distributed and independent, and the measurement of errors were very small in model fitting as well as model verification. Therefore, it was a successful model for the purpose. Then the ARIMA model was tested. Actually, several ARIMA models was tested, and the best fitting model was this: yt equal to yt minus 1 minus yt minus 2 plus a constant and the error component. So, according to the ARIMA, leg 1 and leg 2 are significant, and leg 1 error also was significant. Measurement of errors of the model were not satisfactorily small, but the main problem was errors were not normally distributed. For the ARIMA could not be recommended for forecasting, the performances of ARIMA and Sama circular model were compared using the fitted values. In this graph, the blue line is actual data kept for the verification period, and the red line is Sama circular method forecast, and the green line is ARIMA forecast. You can see that the Sama circular model and actual index, they go together, they move together. That means Sama circular model forecast follow the pattern of the actual data, but the ARIMA forecast follow some other pattern. That's what the literature says. So based on this graph also, we can see that the Sama circular model forecasts are more close to the actuals. What I concluded in this study were the Sama circular model is suitable for the purpose of the study, that is forecasting Indian stock market large cap companies. And findings of the study align with the literature, that is patterns of the actual data and ARIMA forecast are different, and SCM is superior to ARIMA in forecasting wave-like patterns. Share market investments are exposed to two types of risks: systematic and unsystematic. What are they? Systematic risk is associated with every company. They are like political influences, natural disasters, like taxes imposed by the government. So every company is imposed to them. Unsystematic risk is company-wise. Say for example, if there is a strike in a company, it is affected to the company. It is unsystematic risk. Company-wise risk. So when investing in a stock market, unsystematic risk can be mitigated or reduced by diversification. Forecasting helps for diversification. What is diversification? Instead of investing the entire wealth in one company, an investor can invest his or her wealth in several companies, maybe in several sectors. By looking at the return and risk of those companies and sectors, investors can decide where to invest and when to invest. So it is recommended to test the Sama circular model on forecasting share prices or returns of individual companies listed in Bombay Stock Exchange. Also, it is recommended to use the Sama circular indicator in measuring the risk of returns. That would give insight for investors for their investment decisions. Thank you very much.